Hello and welcome to this presentation on working with time data. My name is Cameron Smith and my co-presenter today is Brandon Cree. We're both developers on the ArcGIS Online team here at Esri, and today we're going to talk about time-enabled spatial data and how we can leverage it to create informative visualizations. So the roadmap for this presentation, first we're going to start off talking about the visualization approaches, and there are two of those. The first is smart mapping drawing styles in ArcGIS Online, and the second is animations using the time slider widget from the JavaScript API. And in the second part, Brandon and I will be working through some demos showing you how to put these techniques into practice. So for time visualizations of spatial data, the first thing you want to keep in mind is that they're not always straightforward. Just because you have a time-enabled layer doesn't mean you know right away what the best visualization is that you can create with the data. The visualization that you do end up creating depends heavily on the story that you want to tell with the data. And in order to do that effectively, it requires you to be familiar with your data, to know how it's structured and what it represents. Okay, keeping that in mind, we're going to take a look at the first time visualization approach, which is smart mapping drawing styles. These are available in the 4X map viewer, and to learn about them, we're going to take a look at two examples here. So the first example we're going to look at here is a data set on water main pipes for a city. So we're going to look at the table of the data first, and we see that there's a column called install date, which has the date field of when the pipe was installed. And so we're going to use that in a time visualization. So if we come over to styles here, and for the field we pick install date and hit add. So what's going on here is that the map viewer is seeing that the install date is a date field, and then it's recommending styles for time visualizations. And so what we want to do for this visualization is emphasize older pipes. And so in order to do that, we're going to pick continuous timeline size. Then we're going to go into the style options here. And there is a gradient here for the size based on the date. And we're going to invert the gradient so that older pipes are a larger size. And we're going to take this tab here and bring it down to 1970. Right about there. So what this is showing is that pipes installed before 1970 are greatly emphasized by their width on the map here, and pipes installed after 1970 are less emphasized. Okay, so for our next example, we have a data set of rooftop water tanks for New York City. And if we come and look at the schema for this data, we're going to see that there is a field called inspection date, which is a date time field that shows the last date that that specific water tank was inspected. So we can use this for a time visualization here. And so just like before, we come into styles and pick our date time field, and then it's going to recommend us drawing styles that use time. And so this time we're going to use the color and size drawing style, and we're going to go into style options here. And so now this gradient ramp represents both color and size. And so we're going to invert this, and then you're going to see as we bring down this tab, a pattern is going to emerge out of the data for us. And as you go down, you kind of see this style that we're putting on puts a very great emphasis on the water tanks that haven't been inspected in a while. And so the large circles and the very dark color give us a very great contrast between water tanks that don't need to be inspected and ones that do. And so in contrast to that approach of creating a static time visualization by applying a style to a date time field, we can also create a time animation by utilizing the time slider widget out of the JS API. And so this is a sample from the JavaScript API that shows the time slider widget. So we can press this play button and it is going to play through the precipitation forecast for the next 72 hours. So it's taking this time-enabled data concerning precipitation, and the thumbs of the time slider widget here are specifying a time extent, and then pretty much we're just showing the data for that single time extent, and then ticking through the time extent to show how the data changes over time. And so this is a lot different from the style time visualization that we saw before, in that the styling here is based on something other than the time field. But what we're doing is taking a section of the data and showing it at a certain point in time. So the styling here is for precipitation. We can take a look at the legend here. And we are literally sectioning off, showing a slice of the overall data that we have for a particular time extent. Okay, so our first demo here is on white nose syndrome in bats. And so white nose syndrome is a disease in bats that originated in upstate New York in 2007. It was a novel disease and people don't know where it came from, but from its origination in 2007, it spread throughout the US and Canada, and it's also extremely fatal to bats and has, at some sites, has killed 90 to 100% of bats. So we have data here on the spread of this disease, and we can use the techniques that we've seen to tell the story of how it has spread throughout North America. So we're going to take a look at the data for this, and we'll see that for every county or district that white nose syndrome has spread to, there is a date field here that shows the initial time it was observed in this county. And so we use this in a style visualization. And we put on, for continuous timeline, we're gonna pick a symbol color ramp here. And what we wanna do is have a clear light to dark ramp that shows the spread appropriately. So what we're seeing here is that it originates in the lighter colors, and then you see the spread progressively go out to the darker colors. And this shows the geographic progression of the disease through the bat populations in North America. All right, so now we're gonna add in the JavaScript API time slider widget to make this visualization even better. And in order to do that, we're gonna go over to CodePen. And so we've already got set up where we're adding the web map that we just created and to a map view, and that's being shown in the UI here. And so now we're gonna add in the time slider widget. In order to do that, we're gonna import the constructor, and then we're gonna call that constructor, and then we're gonna add it to the map UI. If I save this and run it, we're gonna see it in the UI now. And you'll notice that for the mode, we're specifying cumulative from start, and that's gonna make it so that as the time slider ticks along, it's showing all of the data from the beginning to the end thumb on the time slider. So if I let this play, we're gonna see that it really does show the progressive spread through time of this disease. So we can make this visualization a little bit better by adding in a statistical query that updates with the time extent change. And so what we just added in is going to count the number of counties that are infected for a given point in time. And you see as the time slider ticks through, it's going to update the amount of counties infected. So really quick, how we do this is we get a reference to the DOM where we're going to be displaying the number. And so we get a reference also to the layer, the white nose bat layer for the counties. And then with the time slider, we're watching the time extent property on the time slider. And then every time the extent changes, we rerun this statistical query. And then we end up with the proper count of counties. We end up updating the inner HTML for the display. And so with this, we end up with this visualization. And so having accomplished this, we're going to move on to some more demos, and I'm going to pass the presentation off to Brandon.
Thanks, Cam. I'm going to do a walkthrough on creating apps with time-enabled layers. We'll go over how to create a time-enabled feature layer using GeoJSON data and creating an app with that layer. How to create a time offset app with a GeoJSON layer. Configuring the time slider widget, and filtering features when the current time extent is updated. The first step to creating a time-enabled feature layer is publishing your data. Navigate to My Content, click Add Item, and in my case, I'm going to select From Your Computer, and then choose a file. The data that I obtained shows the history of wildfires in California over the past century. It's in GeoJSON format, which allows us to see a history of the spatial and temporal distribution of the fires. This data is from California State Geoportal, which is an open data site. Open data gives the public access to authoritative geospatial data from government entities. Make sure that Publish this file as a hosted layer selected, give your layer a title, and then give it tags. Next, we'll click Add Item. The upload process will take some time. Now that this upload is finished, we need to enable time settings for this layer. Click the layer, and on the bottom right, you'll see time settings. Click the edit button and check Enable Time. I'm going to select time ranges with a start and end time. For the start time, that's the recorded start of the fire, and the end time is the recorded containment of the fire. Click OK to update the layer. The first step to creating an app with our time-enabled feature layer is, of course, adding that layer to a map. We do that by using the feature layer class and in its URL property, adding the layer service URL. Next, I added a definition expression, so we're only looking at data after 1999. So if we look at our map, we can see 2 decades worth of wildfire data, from the year 2000 to 2019. With 2019 being the last year available. I then added a pop-up templates using the fields in the dataset and gave them a readable label. I added some styling directly to the layer by utilizing ArcGIS Online's visualization tool. This allows us to style our layer, so I gave it a red background with an orange-yellow border. For the web map, I use a dark gray canvas base map so that our wildfire layer pops on the map, and add a row hill shade to add more geographical context. Then added our feature layer to that web map. Since we're focused on Southern California, I added scale and center properties to our map view so that we're focusing on this area when our map is loaded. I then added some constraints so that we'll only see data for this area. This also prevents the user from moving the map somewhere beyond our area of interest. The next step is adding the time slider widget to our app. In the container property, we add an element object or the element's ID, the latter of which we're using here. And then add the play rate of the animation steps for the time slider, as demonstrated now. When the layer view is loaded for our feature layer, we add our full time extent. The full time extent is the temporal extent of the slider. Since we're only looking at data from the year 2000 and on, we have to add dates from the start to the start and end property. A visual representation of the full time extent are these two dates here and here. The values property is the starting location for the time slider stumps. Since we're using the time window mode, we have two values. The other three modes, instant, cumulative from start, and cumulative from end, have only one value. This is our starting location, and this is our end location. Lastly, we use the stops property to define specific location for the thumbs to snap to. Since we previously set the feature layer's time interval, when we updated the rest, we can use that value. So if we look at our time slider widget, we can see the current time extent at the top changing in monthly intervals. You might have noticed that when we move the thumbs on the time slider widget, our feature layer hasn't updated. We will add the final piece next. The last step is using the time slider's watch method to detect changes in its time extent property. In the watch method, we add a feature effect to the layer view's effect property. This filter property is autocast to a feature filter. In this feature filter, we're going to add our time slider's time extent, which is an object containing the current start and end dates in our range. Our geography is set to the extent of the view, which we previously constrained to Southern California. Then we added an effect to the excluded effect property. This will apply the effect that we set to the features, wildfires in our case, that aren't inside the range in the time slider's time extent. Since we've applied opacity 0 to this, features that aren't in this range will be hidden on the map. When I hit play, you'll notice wildfires appearing and disappearing as the current time extent moves. Note, I updated the play rate to 1 second and the time slider's time stops interval to 1 year. Features effects only works for 2D maps, so if you're going to be working with the 3D scene view, use feature filter because the effect property isn't available for scenes. I also added an info div that updates with relevant stats when the time extent is manipulated. These three objects are the statistics definition that we'll be using in our query. OnStatistic field is the name of the field in our dataset that we want to use. OutStatistic field name is the output field name that we'll get after our query. And the statistic type is the type of calculation we want to make. For example, for GIS acres is the name of the field in our dataset. And we're looking for the total acres burnt, so we use the statistic type sum. We use the feature filter's create query method to fetch features that are in our time extent and then add the definitions that we made above to that query. Next, we query the feature layer, and then we use those results to get the stats for the info div. Finally, we put the info div inside an expand widget and add that to our view. In this example, I added an included effect, which applies an effect to the features that are in our current time extent, and changed the effect of the excluded effect to show a nearly transparent feature that's also been grayed out. This allows us to continue to see the entire history of wildfires in our full time extent, but at the same time keep the focus on features that are in our current time extent. I added bloom and blur to the included effect property. Both of these are new effects that were added recently in version 4.18 of ArcGIS API for JavaScript. Drop shadow being the other new effect. If you look at our map, you can see a glow spread from each feature, intensified when more features are added in our time extent. Since some effects, particularly these newly added ones, can be sensitive to scale, 4.18 also introduced scale-dependent effects. I over-exaggerated the bloom for this included effect to better display the difference between scale-dependent effects. As we zoom in, you'll notice that the bloom intensifies. And when we zoom out, it lessens. Scale-dependent effects should be used to fine-tune or control effects at different scales. Scale-dependent effects are arrays of objects where you specify the scale, and then in the value property, add the effect you want for that scale. The API will interpolate the effects between scales. Just remember to keep the type and order of the effects consistent throughout the array, or the effect will be set to null. For this last example, I will go over how to create a time offset app, but instead of using the feature layer that we created before, I will use raw GeoJSON data. I will skip over parts that we've already covered. First, we need to create an array that contains objects with the year and appropriate offsets that we need. I will get back to the offsets later. In our create layer function, we are returning a time-enabled GeoJSON layer. In its URL property, we added a URL that points to our raw GeoJSON data. And here's that data. In the service URL's query parameter, we're going to add the year from the definition array we made earlier. This will give us 20 unique layers, starting with data from the year 2000, going up to 2019. The renderer here gives each feature in our layer a red background with an orange-yellow border. Next, we add the time info property and add alarm date to the start field and containment date to the end field. By adding both, fires that span multiple months will remain on the map until that fire is contained. The time offset property allows us to overlay features from multiple time-aware layers. The definition array that we created earlier has an offset value. This value will shift the layer's data to 2019. For the year 2000, the offset is 19. The offset continues to decrease as the years increase until the offset is 0 for 2019. Layers is an array of our GeoJSON layers. It's created by mapping through the definitions array and returning GeoJSON layers from the create layer function. I've added a map view to the time slider widget. This will filter out excluded features without having to add a client-side effect to the layer view, like we did in our previous example. In the full time extent property of our time slider, we add the first date and the last date of 2019 as our start and end points respectively. This is because of the time offset shifting all the layers data to 2019. Here, we're only using the time slider watch method to update stats in the info div. In the update fire stats function, we use the layer view each always function to get an array of promises. When that resolves, the results, which includes the layer views for each of our layers, are passed into the query features for stats function. When that function's promise is resolved, we get the stats for each of our GeoJSON layers. With those results, we can add the total acres burnt and the total fires that are in our current time extent to our info div. Then, of course, we add that info div to the map using the expand widget. To summarize, with CAM, we saw the two different time visualization approaches with the smart mapping drawing styles and the animations with the time slider widget. We also did a walkthrough on creating apps with time-enabled feature and GeoJSON layers, how to create a time offset app, and filtering features. Thanks for watching. Hope you learned a lot. Provide your feedback for this session by clicking on the session survey link below.